All right, let's get into this next example. Just something I want to bring up, which you may or may not have to deal with, but why not talk about it? Even if you don't have a table, 9 times out of 10, you can make a table given the information that you have on a particular problem. So, for instance, if you have a graph on any problem involving linear functions, that is probably going to be the easiest problem that you're going to have on that assignment because you can look at this graph, you can see the slope, you can see the y-intercept, and you can see all the points that are inside of the graph on the function, on the domain between -6 and 6, and I'm sorry, the domain between -6 and 6. Yeah, and a range between -6 and 6. Range of being up and down, domain being left to right. So if you just look at the points, you can put those coordinates in the table. So this point, x -2, y +5. Next point, x, the x number is at 0 and the y is at 4. Okay, right here, the x number is at 2 and the y is at 3. So the coordinates are 2, 3. And then, of course, the next point is the y number is at 4 and the x number is at 4 and the y number is at 2. So that is the coordinates 4, 2. All right. So with those points, if we have common differences on the domain side and over here on the range side, then we can find the slope and hopefully we can find the y-intercept if there's a 0 right here on the x side. All right. So what is the domain on this side going from -2 to 0? That is a +2. From 0 to +2 is 2. And then from 2 to 4 is 2. So it is going up by 2 on the x side. Let's check the range side, which is the y. And you have 5 to 4. Notice that's going down by 1. So that's -1. 4 to 3, -1. 3 to 2, -1. All right. So we use those numbers, those differences, to figure out the slope, which is rise over run. The rise is the y side. The run is the x side. So -1 over 2 is my slope, which is a -1/2. Now on this picture, there is a y-intercept, which is 0, 4. Okay, but when we put the y-intercept into the slope-intercept form, it is only the number under the y that we use, so that b is equal to +4. So that gives our equation as -1/2 x plus 4. We could say y is equal to -1/2 x plus 4, or we could say f of x is equal to -1/2 x plus 4. And there's just another example of how we can use the table to determine the linear function. Okay, it's not that hard.